Guys, are there any questions over the homework assignments before we get started? All right. What we're looking at today is a special type of factoring. And it's the difference of perfect squares, or difference of two squares. If we have two terms that are perfect squares and they're being subtracted, we can factor it in the form of a plus b times a minus b. So if we look at the example they gave us here, x squared minus 9, a, in this case, is going to be x, because x squared. B, our b term that's being squared, so 9 squared is going to be 3 squared. A is x, b is 3. So we get x plus 3 times x minus 3. So if we wanted to, we can get x squared minus 25 in the form of a squared minus b squared. We just have to figure out what times itself is going to be x squared and what times itself is going to be 25. Well, x squared is x times x, or just x squared. Now 25, we have to figure out what times itself is 25, which is 5. Because 5 times 5 would indeed be 25. So our a term would be x, and our b term would be 5. So the first part, a plus b, for us here would be x plus 5. And it's going to be multiplied by a minus b, which would be x minus 5. So x squared minus 25 is going to be x plus 5 times x minus 5. Questions on this here? We're ready for the next one. Our next one, 4z squared minus 1. So we can get it in this form of a squared minus b squared. So if we get it in this similar form, 4z, we're going to rewrite it as a term being squared, and we're going to rewrite 1 as a number being squared. So if we look at 4z squared, we need to see what times itself is 4z squared, or we can break it into parts. So we're trying to figure out what times itself is 2, or 4, which is 2. And z squared would be z, because 2z squared, 2z times 2z, or 2 times 2 is 4. Z times z is z squared. Now we need to figure out what times itself is 1. 1, because 1 times 1 is 1. So this here is a difference of perfect squares. And we can factor it in the form of a plus b times a minus b. A in our case is 2z. So we'd say 2z plus 1 times 2z minus 1. That's it. Questions on this here? X squared minus 64. So we can get into this a squared minus b squared form. Well, our a, so x squared would be, well, x squared. And 64 would be 8 squared, because 8 times 8 does give us 64. X times x gives us our x squared. Now our a plus b would be x plus 8. Our a minus b would be x minus 8. Questions on this here? X squared minus 36. "36" would be 6 times 6. If we're not sure, if you're having trouble finding what times itself is that number, we can take the square root. Square root of 36 is asking what times itself gives us 36, and it would be 6. And what times itself gives us x squared? Well, that would be x. So this would factor 2. X plus 6 times x minus 6. Questions on this here? "100 minus m squared." Now, even though the variable is second, it doesn't matter. We can still keep the same form. What times itself is 100? What times itself is m squared? M. So this would become 10 plus m times 10 minus m. Questions on this here? 9n squared minus 16. "16 would be 4. 9n squared would be 3n. "16h squared minus 49. Let's say g squared. Let's add that in. "16h squared, so 4 for 16 and h for our h squared, because 4h squared would get us back to 16h squared. Now 49g squared would indeed be 7g. Now, as we notice this here, even though we had variables in both spots, it really doesn't make a difference. It's still going to factor the exact same way. Questions on this here? "25b squared minus 36. 5b squared minus Questions on any of this so far? Let's add one. 32x squared minus 50y squared. What times itself is 32? Well, we can check and see. Square root of 32, square root of 50. There's not a number that multiplies by itself that gives us 32 or 50. So we can look back at this here. Is there a greatest common factor between these two terms? And it is 2. 2 goes into 32 and 50. And if we factor 2 out of 32, we get 16. If we factor 2 out of 50, we get 25. So because there was a greatest common factor 2, we pull it out. 16x squared minus 25x squared is indeed a difference of perfect squares, which would have been 4x and 5y. So this one still does work the same way. We just had to get that common factor of 2 out before we could use our difference of perfect squares formula. Interestingly enough, if the greatest common factor of the two terms is a perfect square, it still factors in this form. Are you ready for the next one? Use a special product pattern to evaluate the expression 54 squared minus 48 squared. So essentially, we're doing what we've just been doing. A in our case would be 54, B would be 48. So we can say it's 54 plus 48 times 54 minus 48. So the first thing we can do is add 54 and 48. And we would get 102. 54 minus 48 is 6. Now all we have to do is multiply 102 and 6. Yeah. Because 54 squared minus 48 squared is 612. Ready for the next one? So here we would do what? 62 times 68. I think we're good with doing one more. Yes, 36 squared minus 34 squared. Is, I mean, we're just subtracting two numbers that are being squared. 140. Yeah. Now, if you don't have a calculator, trying to do these by hands would take a while to actually square 47 and square 44 and then subtract them. This is a nice shortcut if you don't have a calculator. If you have a calculator, it'll do those nicely. 3 through 12.